Today I'll talk about functional groups and naming of organic compounds. Functional groups are the sites where a chemical reaction may occur in an organic compound. So it's important to know the different types of functional groups that are present in an organic molecule. So let's look at some of the functional groups. So I have a bunch of functional groups here, and we'll go and name each of these functional groups. Let's start with the first group on the left here, this OH group. That's the hydroxy group. And so the molecules that have the OH group are considered to be alcohols. And then we have the halides. Here I have just the bromide, but it can be a chloride, a fluoride, or a iodide, and they're all named as haloalkanes. Then we have aromatic rings like benzene, and they are called aromatic compounds. This functional group is an aldehyde. The reactive site here is right here at the carbonyl. And this SH group is considered to be the thiol group, and the compounds are all considered to be thiols. And then we have ethers. This one, NH, is the amine group. So even if this hydrogen is replaced by an alkyl group, it's still considered amine. This functional group is acyl halide, and Br can be replaced by any of the halogen atoms. And acyl halides are very reactive. The CN group is the nitrile group. It's also called the cyano group when it is considered as a substituent. And then this one is the ketone or keto group. This is carbonyl group, and this is the reactive site. And all compounds bearing the carbonyl group attached to two alkyl groups are considered to be ketones. This functional group right here is the carboxylic acid group. So this is the carboxyl group. This is the acidic hydrogen right here. And then we have alkenes, which have the double bond right here. So this is an alkene. Moving on, this is an ester. So this is a carboxyl group which is converted into right here ester. So this is an alkyl group. So this functional group is an ester. They are also pretty reactive. And then we have the alkynes, in which we have triple bonds between two carbon atoms. This is, you won't come across an anhydride very frequently, but they are also used in organic chemistry. And finally, the last functional group is an amide, where the carbonyl group is attached to a amino group. Amides, the rotation between the carbon-nitrogen bond is very restricted because of the lone pair of electrons that can, get delocalized. And because of that, the carbon-nitrogen bonds are very restrictive in an amide. So these are some of the typical functional groups observed in organic molecules. So let's see how we can name an organic compound with so many different functional groups. So there is a priority list for the functional group, and I'm going to show it to you right now. And we need to follow the ranking of the functional group while naming an organic compound. So the ranking of the functional group increases from left to right. As you can see, halide has the lowest ranking, and carboxylic acid functional group has the highest ranking. What that means is, if a molecule has a carboxylic acid, then that will be the kind of the parent chain or parent name. So here are the rules for naming inorganic compounds. First, you have to select the longest carbon chain with the highest ranking functional group, and that is considered to be the parent chain. The next rule is all other groups that are attached to the parent chain are considered to be substituents and are named accordingly. If an alkene or an alkyne is in the parent chain, then we use the ene or the yne before the suffix of the highest ranking functional group. So you have to keep that in mind. And if ketone is a part of the parent chain, then we introduce the word oxo before the name of the parent chain. Also, we include the number as a prefix before oxo to indicate the location of the ketone group. And finally, we number the parent chain starting from the highest ranking functional group. So for example, if the molecule is an ester, then that's the highest ranking functional group, and all other substituents which have lower priority will be considered substituents if they are attached to the parent chain. We also use the prefix di, tri if there are several of the same substituents. So if there are two alcohols or OH groups, then we can say it's a diol. If it's three, we can say it's triol, and so on and so forth. So in order to name the entire compound, we will list all substituents in alphabetical order, preceded with a number to indicate the location, followed by the name of the parent. So let's look at the names of the functional groups as substituents of the parent chain. So let's start with halogen. So halogen is represented by X right here, and fluoro, chloro, bromo, and iodo nomenclature is used to identify the halogen as a substituent on the parent chain. If an alkyl group is present, the alkyl group is an R group, considered to be the R group. It's symbolized by R. And we'll have appropriate names. I'll cover all the different types of alkyl groups that you may encounter in an organic molecule. Then you have the cycloalkyl groups like cyclopropyl, cyclobutyl. These can also be substituents. Then you can have a double bond as a substituent, and if a double bond is a substituent, it's considered to be alkynyl. Okay, example will be ethynyl. And if a triple bond is a substituent, then it will be alkynyl. Example will be ethynyl in case of, from acetylene. And then you have amino groups, NH2, or it can be NHR. So these are the amino groups that will be the substituents. And then we have thiol. So if thiol is a substituent, then it's considered, thiol is the SH group, and it's considered to be the mercapto group. So that's how you have to name it. That's the IUPAC name of the substituent. If you have the alcohol, that's the OH group, and the alcohol is a substituent, then it's considered to be the hydroxy group. If nitrile is a substituent, then the CN group is considered to be the cyano group. And then if you see an ether like OR, where R is an alkyl group, in this case it's O-methyl, so this is methoxy group. You can have ethoxy group, propoxy group, and so on and so forth. So the naming convention is alkoxy. So whatever the name of the alkane is, and then you would add the word oxy to it. And then finally, if benzene is a substituent, it's considered to be the phenyl. It's named as phenyl. So let's look at the names of compounds with the different functional groups. So the first one you may be aware is hydrocarbon RH, and that's considered to be the alkane. These are very inert organic molecules. Then you have RX. X stands for any halogen, fluorine, chlorine, bromine, and they're considered to be the haloalkanes. Then you have OH group. When a OH group is attached to an alkyl, it's considered to be alkanal. And in this case, you can see the E of the alkane is replaced by OL. And then you have, when SH group is the functional group, it's considered, the compound is considered to be alkane thiol. So if it is if R is CH3, then it will be considered to be methane thiol. And we'll look at some of the examples of these compounds. Then you have a double bond right here. So this is an alkene. And if it's a triple bond, it's considered to be alkyne. In this case, this is CHO is the aldehyde group, and the compound function and the compounds are called alkenyl. So you can see the E of the alkane is replaced by Al. And then this group of compounds is called the ketones, and they are named as alkanols. So this is CO is the ketone functional group, and the compounds are named as alkanol, where E of the alkane is replaced by ONE. And then you have the ester group. Whenever ester group is present, this is a COO group. Then you name it as alkyl, alkanoid, and this alkyl is the alkyl group attached to the oxygen. And then you have the carboxyl group, and so the compounds are named as alkanoic acid. When NH2 group is present in the molecule, it's called an alkane amine. So the E of the alkane is replaced by the word amine. And then you have CN group, which is the nitrile group, and you name the compound as alkane nitrile. You just add the word nitrile after the alkane name, just like we did for thiols, where we had alkane thiol. And then the last one is the amide, where we name it as alkane amide, where E of the alkane is replaced by the word amide. So these are the names of the compounds with different functional groups, which you will encounter in organic chemistry. Now let's look at some examples. So let's look at the IUPAC names of some simple organic compounds. So these are organic compounds with one functional group. Try to name them based on the rules that you have learned so far and the naming convention. And once you have done that, you can check the answers. So let's start from the leftmost molecule here. This is an alcohol, OH, and you have 3 carbon atoms, so it's propane. So the E of propane is replaced by OL in the naming of the molecule, and the OH group has a higher priority over the halogen, which is in this case the chlorine, and so the carbon bearing the OH group is numbered 1, and the chlorine group is attached to carbon 3. So the compound is called 3-chloropropanol. Let's consider the second example. In this particular case, the numbering is from the left, 1, 2, 3, 4. When you do that, the ketone group has, carbonyl group has the number 2, but if you start numbering from the right, from here, and say it's 1, 2, and 3, so you don't want the keto group to have a higher number. So this is the correct way you need to number it, and the compound is called 2-butanone. In this case, since it's a 4-carbon atom, the butane E is replaced, the alphabet E in butane is replaced by ONE, on. Let's look at this thiol. The SH group is considered a thiol compound, and so you just name it based on the hydrocarbon. In this case, it's 3-carbon unit, so it's called propane, and then you add the word thiol. In this particular case, this is a double bond, and the 2 methyl groups are opposite each other, and so they're trans. And the location of the double bond is on carbon atom 2, so you call it trans 2-butene. Butene because there are 4 carbon atoms in the longest chain. To learn more about the geometric isomers of double bond, please refer to my video on classification of isomers, and you'll learn more about cis, trans, double bonds, as well as cis, trans in rings. Let's look at the example. In this particular example, there's a triple bond right here, and it's on location carbon atom 2, so you call it 2-butyne because it's a 4-carbon molecule. Let's look at some additional examples, try to name this, and once you have written down the names, then you can check the answers. So this is a carboxyl group, and there are 6 carbon atoms. Remember that you have to number the carbon atom as 1, which bears the carboxyl group, and that same is true for the carboxyl group or the amide group or the ester group or the aldehyde group. Okay, always number the carbon atom for these functional groups as carbon 1, and then you have 6 carbon atoms, so it's called hexanoic acid based on the naming convention. If you look at this example, it's derived from propane, so it's called propane amide. So in this case, the E of propane has been replaced by the word amide. This is an ester, and in case of esters, you will first put the alkyl group name of this particular alkyl, which is attached to the oxygen. So this is a methyl group, so you call it methyl, and then this is butane, so you get butanoate. So the E of butane has been replaced by the word OH, so the compound is called methyl butanoate. This is an aldehyde, and it's called ethanol, where the E of ethane is replaced by the words Al. And then you have a simple alkyl halide right here. The numbering is done from the end of the carbon chain, so in such a way that the halogen has the lowest number, so that's the reason you number from this end. So you say 1, 2, 3, 4. You do not number it from the other end, because if you do that, then bromine will be on carbon atom 3, and that is not the right numbering. For that reason, this compound is called 2-bromobutane. Butane because there are 4 carbon atoms in the chain. Let's look at some more examples, and then you can, once you have written down the names, you can check the answers. So the first one is simple and straightforward. It's a hydrocarbon, 6 carbon atoms. It's called hexane. Next one is, this one is called 2-butanamine. This is the naming convention for amines, so that the alkane, in this case it's butane, the E of butane is replaced by the word amine. That's the reason it's called 2-butanamine. And then you have the nitrile group right here, and in this case the naming is the name of the alkane, and then you add the word nitrile, which is very, very similar to how you name thiols, where you have the name of the alkane followed by the word thiol. So these are some of the IUPAC names of compounds that you may encounter in organic chemistry, and that will help you, write the names of more complicated compounds, and we'll cover those examples also. So now let's look at some of the common IUPAC names of alkyl groups. So this is the neopentyl group. Neopentyl is the common name, and you can see you have three methyl groups attached to this carbon atom, and there's a CH2 group right here. So this is the neopentyl group. And the IUPAC naming convention is such that the carbon atom, this is the carbon atom that is attached to the parent chain. So this carbon atom is numbered 1, and this carbon atom is numbered 2, and then you have 3. So 1, 2, 3. So that's the naming convention. And then you have two methyl groups attached to carbon atom 2. So that's the reason it's called 2,2-dimethyl, di because two methyl groups are there. So 2,2-dimethyl propyl because it's attached to the propyl chain, and that's the IUPAC name of this alkyl group. And it's also represented this way. So whenever you see a structure like this in an organic molecule, then remember that this is the neopentyl group. So the next one, that is this particular alkyl group, is called sec-butyl group, and it's one methyl. It's called 1-methyl propyl. 1-methyl because methyl group is attached to carbon atom 1, and this is the carbon atom 1, and this is the methyl group that's attached. And this one is the T-butyl group right here. So if you see something like this, it's called the T-butyl group, and the IUPAC name is 1,1-dimethyl ethyl. Ethyl because this is the two carbons, so it's called ethyl. And this is a simple. So these are all branched chain alkyl groups, and then this ethyl group is a unbranched alkyl group. And it's represented like this in organic molecule. This is the CH2 group, this is the methyl group right here. Then you have a methyl group, which is CH3, and this is another branched alkyl group right here. It's commonly found in organic molecules, and this is the isopropyl group. This is the CH carbon right here. And then you have the straight chain alkyl group called propyl, because there are 3 carbon atoms. So remember that the alkyl groups are named such that you start with the parent name of the alkane. In this case, it will be propane, and the ane is replaced by YL to make it propyl. Same with from methane. You replace the ane with YL to get the methyl. Same with ethane, you replace the ane in ethane with YL to get the ethyl. So that's how the alkyl groups are named. This is another alkyl group. It's called the isobutyl, common name, and the IUPAC name is 2-methyl propyl. So now let's look at examples. So this is an example, and let's try to name it. So in this particular case, you have 2 carboxyl groups. You can number it from this side, or you can number it from this side, or either side, it's fine. You'll get the same name. So there are 2 carboxyl groups, and there's a double bond. So both the carboxyl groups are on the same side of the double bond, and so it's called cis. So this compound is named as cis 2-butene dioic acid. Now we add the word di in front of oic because there are 2 carboxyl groups, and the 2 carboxyl groups are cis, and the double bond is located on carbon 2. So you use 2-butene. The ene represents that there is a double bond in the molecule. Let's look at another example. In this particular case, let's try to list the substituents. So the substituents that are present in this molecule is the methoxy. OMe is called the methoxy. Remember, the methoxy word is derived from the standard alkoxy word, where meth is the prefix of methane, and then you just have anoxy to the prefix, and then you have the bromo as an additional substituent. And in this particular case, if you recall, if there is a OH group between all these 3 functional groups, the OH group has the priority over the triple bond and the halogen. Alkoxy groups are always considered to be substituents. So because of that, you start numbering from the carbon atom that's attached to the OH group. You say 1, 2, 3, 4, 5, 6. And then you start naming the organic molecule as 4-bromo, 3-methoxy, 5-hexyl. So remember, this naming is in alphabetical order. So bromo comes first, and then it's methoxy. And then you are the number 5 is to indicate the location of the triple bond. So 5-hexyne, that's YN, and then you end with OL because it's an alcohol. So that's how you name a compound which has a triple bond and alcohol. So let's look at this molecule. Let's see the substituents on it. So the substituents are the methyl group right here and the phenyl group, and the numbering is from the carbon atom bearing the aldehyde. This is the aldehyde functional group, if you recall. So you start numbering from here: 1, 2, 3, 4, 5, 6, 7. So the phenyl group is located on carbon 7. So you name this compound as in alphabetical order again. So methyl will come first, and then you say, and you always put the number before each of the substituents to indicate the location of the substituent. So methyl group is on carbon 4, phenyl group is on carbon 7, and then you call it heptanyl. So it's, since there are 7 carbons, so the parent chain is heptane, and the E in heptane is replaced by Al because this is an aldehyde. Let's look at another molecule. In this particular case, you will see that if you recall, this is an ester group, and ester group has priority over the nitrile and the double bond. So the nitrile is considered to be a substituent on the parent chain. So this is the parent chain. So you always number the ester group starting from with number 1. So 1, 2, 3, 4, and 5. And in this particular case, the double bond is within the parent chain. So the substituent is, even nitrile CN group is the substituent. It's called the cyano group. And so the way you name this ester is, remember that you have to name the alkyl groups that is attached to the oxygen first. So this is an ethyl group, so you call it ethyl, and then you say 3-cyano, 4-pentenoate. So 4 represents the location of the double bond, and then you have the ene to represent the double bond, and then you have the O8 to represent the ester functional group. So that's how you name this molecule. So let's look at another example. In this particular case, it's a pretty long carbon chain. You can see it's a 10 carbon chain, so it's the parent alkane name is decane. You start numbering it from the, this is the amide functional group. You start numbering it from this carbon 1 to 3 because the amide group has a higher priority over a OH group and a double bond. Remember the rules of the ranking of the functional groups. And there are two methyl groups in this case, so you'll use the word dimethyl in this case. So let's list the substituents. So there are two methyl groups and one OH group on carbon atom 7. The OH group is on carbon atom 7 and the double bond is on carbon atom 5. And this is how you name it. You call it 7-hydroxy 3,3-dimethyl. So you have to put the number for each of the methyl groups. So in this case, since the methyl group is on the same carbon atom, you repeat the numbers. So it's 3,3 and di because two methyl groups are present in methyl. And then you add the word number 5 to indicate the location of the double bond. So you call it decene. Ene is used to represent the double bond, and then you end the name with the word amide because there's an amide functional group, and that's the parent chain. Let's look at another example. In this particular case, this is a ketone. This whole molecule is ketone. You have the carbonyl group right here. You start numbering it from the end so that the keto group has the lowest number. So you 1, 2, 3, 4, 5, and 6. This NH2 group is a substituent on the parent chain, and so it will be called amino group. And then you have a double bond, which is part of the parent chain. And so these are the substituents are methyl and amino, and this compound is called 5-amino 4-methyl 3-hexene 2-on. In this particular case, I have not kind of listed the stereochemistry of this, but if you have to list the stereochemistry, you have to look at the substituents that are attached to each of the carbon atoms. So between the two substituents attached to this carbon atom, this has a higher priority. Please refer to my video on classification of isomers, which explains how the geometric isomers of a double bond are named. And there's a hydrogen here and the carbonyl group here, and so this is a higher priority. So this one is high priority and this one is high priority, so they are on opposite sides, and so it's called E. So you'll have the, you can have the notation E, but in this case I have not put it in there. Then let's look at another example. In this case, this is amine. And then you have the ethyl group as a substituent. The double bond is part of the parent chain, and so it's called 3-ethyl 4-pentene amine, following the standard naming convention. And we have another molecule right here. I think this is the last example. This case, the parent chain this is the parent chain. There are 9 carbon atoms, so it's non-ane, but this is a nitrile. Nitrile has a higher priority over double bond or a thiol group. When the thiol group is a substituent, then it's called the mercaptor group. You can refer back to this video to understand why it's called the mercaptor group when it's a substituent. So this compound will be named as 8-mercapto 6-non-ene nitrile. Remember, the 6 and the ene represents the double location of the double bond and the naming convention for double bonds, and then you add the word nitrile. So there are additional functional groups encountered in organic synthesis, and those are these are epoxide. So you have the oxygen atom attached to two carbon, and it's called the epoxide. And then you have the acetyl, where you have the OR groups attached to two alkoxy groups attached to a carbon. They are called acetals. And then you have the cyanohydrin, where the OH and the cyano group attached to a carbon. And this one is imine, where there is a double bond, carbon nitrogen double bond, and you encounter this in organic chemistry too. This is an enamine, where you have a carbon-carbon double bond attached to a nitrogen right here. So these are some additional functional groups that you'll encounter in organic chemistry. Thanks for watching. Like and subscribe.